Hello, how are you? Take this time and read again. This is time reserved for you to follow the online online content on database. The last time we have seen what is database. We have seen a different definition on database. The basic concept on database. Now, take this time and again revise on database design, the Unity 5. Before thinking about the database design, what is database? It is a collection of tables, collection of information organized. In the future will be the programmer. You have to think about the database. And once you know database, each and every program should have a database. Let us continue on database design. Database design, it is a way of organizing information, of course. But before thinking about the database, you have a question to deal with. You have to search information. Let us take an example. You have a work or you have an activity. You are going to make a program. Of course, you will build what? A database. Then you have to search the information on the work you have, on the question you have. That's why you have to think about the database design. Database design can be implemented in the 3 levels. Of course, there are the steps of doing database design, but let us start on levels. We have 3 levels: conceptual design level, logical design level, and physical level. What is conceptual design level? This level is concerned with the concept, abstract, an idea of what something or how it will work. You think in mind what you're going to do, but you have many different elements to deal with. But the most important in the conceptual level, we have what we call entity relationship diagram. We have in senior 4, before starting programming, you have seen what we call flowchart. Through flowchart, you can make a program. And then, through the entity relationship diagram, you can design a database. Entity relationship diagram, it is a symbols that are designed to represent the concept you are going to describe. The main concept, you have a property, entity, identifier, cardinality, degree, and the relationship. So the first point in the conceptual level, we have what we call the entity. Entity, it is considered as object. It is the main element once you are designing a database. Entity in the entity relationship diagram, it is represented using a rectangle. So we have a different type of entity. So we have entity. It can be weak. It can also be strong. So we have two types of entity. Then what's the difference between the weak entity and the strong entity? A strong entity is an entity that depends on the other entity. A weak entity, it is an entity that is the a weak entity. It is an entity that depends on the other entity. Then strong entity is independent. It is independent. Let us take an example. You are going to make a software where you will need to create database of IFAC, for example. You need to identify the main element: student, teacher, course, row. There, student, teacher, loans, course are entity because they are basic element. And then, if you try to identify the entity, weak entity and strong entity, for example, Max is a weak entity because it depends on student and teacher. Without student and teacher, you cannot get Max. So, student and teacher are considered as a strong entity, and the Max is considered as a weak entity. So we have a different entity. Entity is a set of entity. We can define also entity set. It's a set of entity of the same type that they share the common property. Later, I want to discuss about the property. But you have a different example of entity where we have the concrete. We have concrete. We have an occurrence, something that you can touch, or the abstract. So, for example, student, teacher are concrete because physically you can see a student. You can, okay. These are examples of entities. The point number 2 is the attribute. Once you describe the entity, you have what you call attribute. Characteristics of entity is what you call attribute. For example, a student is characterized by name, ID, registration number, phone number, parent name, place of residence, age, sex are called what? Attribute. In entity relationship diagram, attribute is represented using ellipse. So we have a different type of entity. Normally, attribute or attribute is a data item that describes the property of an entity set. So we have a different types of attribute. We have what we call simple attribute. It is an attribute that is made. It is a single component. It is also called a single value attribute. We have a composite attribute. It is an attribute that consists of many components. For example, if you have a name, it is an attribute that has a component, last name and first name. The address, it is an example of a composite attribute, where the address, even on this figure, address you have a KG 14. Okay. And then after composite attribute, we have what we call Single value attribute, it is like the first one. It is like a simple attribute, single value attribute. After single attribute, we have what we call multi-value attribute. It is an attribute that may have many values. An example of a multi-valued attribute from a company database, a degree. A degree can have master's, PhD, A2, or degree. And then, because they have a degree have different value, it is a multi-value attribute, and it is represented by a double circle or double ellipse. We have what you call derived attribute. Derived attribute, it is an attribute that is calculated from another attribute. For example, age. Age is calculated from the birth date. Experience, working experience, from the starting date. The starting date. So we have the other different types of attribute. You have unstable attribute, you have a mandatory, we have a optional attribute. We have another particular attribute which is called identifier. Identifier is another type of attribute that may distinguish an entity from another one, and it should be unique. For example, in the company employee, it has an attribute that may distinguish one employee from another employee. For example, employee ID. You cannot two employee ID of the same value. If, for example, we have A001, cannot get another A01. If an attribute is unique identifier, it can also be called a key. A key, it is a constraint, or it is an attribute or a group of attributes whose value can be used to uniquely identify an individual entity in an entity set. So we have different types of key. An attribute, before being a key, it should be identifier. Means can be identified from another field. So we have a different type of key. We have a candidate key. We have a candidate key. We have a primary key. We have a foreign key. A candidate key, it is an attribute or set of attributes that uniquely identify a record in a relation. And once a candidate key is selected, it becomes a primary key. Let us take an example of our company. We have an entity called employee. It has a serial number, employee ID, first name, surname, address, contact, birth date, salary. So, the candidate key are attributes that have the criteria for being a primary. That can be uniquely identified from another one. A serial number, you cannot get two the same serial number in the company. So you cannot get two employee value of the same, two employee of the same size, of the same value. That's why serial number can be it is unique identifier. So So a serial number and employee ID are candidate. We see that a primary key is a one of the candidate. So before being a primary key, it should be what? A candidate. And each relation or each table must have a primary key. Once we are creating a database, automatically you are asked to choose primary key. Means a field that can identify from the other one. We have what we call alternate key. It is a candidate key that is not chosen. For our database, employee serial number and employee ID. If you choose the serial number to be primary key, so employee ID it becomes a alternate key. A foreign key, you need two relations. You need two tables, and you combine a key from one table and another key, a field from one table, another field from another table, and it becomes a foreign key. So the purpose of foreign key is to ensure the differential integrity. Later I want to discuss on the rules of database. An example, if you have a company, debt ID is a foreign key. Why? You have two tables, and one table has a employee ID, first name, surname, address, contact, birth date, salary. If you have a debt ID, it means that key it exists. It points to the I may say the parent table. So attribute and key are also what we call the attribute and the key. The key attribute must be unique. So we are in the conceptual level, we have seen the entity, we have seen the attribute, types of entity, types of attribute, and then let us discuss about the keyword called the null. Once you are completing the table, you may jump a cell. If you jump a cell, it means it is not a blank space. A null, it is a special symbol independent of that type, which means that either unknown or inapplicable. It does not mean that zero or blank. If you complete database in a column and you jump a space, so that one is called null. The features of null include no data entry, no permitted in so a primary key cannot be null because you cannot jump a primary key. It is a mandatory because it identifies each record. So here we have a table that is completed, a table called employee. We have employee ID, job title, department, salary, commission. So in the commission, we have you can jump. If there is no commission, it means you can jump that space, but you cannot jump only employee ID. So we have also a relationship set is a set of relationship between two or more entity, and they is represented by a verb. An entity is related to another one, and an entity is represented by a diamond or after relationship. We have what we call degree of relationship. A degree of relationship refers to the number of associated entity, or the degree of relationship can be broadly classified into many types. We have the four types. We have a unary relationship, have a binary, ternary, and number four, it is a quaternary relationship. Unary relationship, it can also be called a recursive relationship. It is a relationship where we have one entity. Binary relationship, it involves two entities. Ternary, it involves three entities, and for four, it involves four entities. Classification of a relationship. We have four types of relationship. We have one-to-one, many-to-one, one-to-many, and many-to-many. You can even give an example. For example, for a country and a president. A president read one country can read two countries, so that is one-to-one. A person may have only one passport. I don't know if a person can have more than two passports. A man has one husband. One-to-many, you can even give your own example. You can give for example, a president of a country and the people. One president can read what? Many people. One teacher can teach many students. That is one-to-many. We have a many-to-one. Many students can be taught by one teacher. We have also many-to-many, where a customer can purchase more than one book. The book are purchased by many customers. So here we have the other figures that indicate the basic symbols that is used in a database. We have a strong entity that is represented by a rectangle. We have a weak entity that is represented by a double rectangle. We have a relationship represented by a diamond. We have associative entity. We have attribute, multivariate attribute, and the other. We have a derived attribute. So the conceptual level is terminated on the entity relationship diagram. So if you are asked to construct the entity relationship diagram, normally is to identify the entity, to identify property, to identify relationship, and join them using what a link. The point 2 on database design level is the logical level. Logical level, you have to put in practice what is done in the conceptual level. Remember that the entity relationship diagram was considered as a flowchart. If you start by writing a program, normally you are in the logical level. Database management system is characterized by a clear sounding. So at this level, at this logical level, you have to think about the model. In the previous unit, we have discussed about the database model, hierarchical, relational model, network model. But if you are in the logical level, most of the time we use what you call relational model. So of course we have the keyword. The keyword used in the conceptual level, they are synonyms in the logical level. For example, if in the conceptual level we have an entity, in the logical level we have what you call relation or a table. here we have a figure that shows the entity, the logical level, where we have employee relation. In the logical level, you can talk about the entity, but you have what you call relation. So relation is known as a table. It is what we call entity. And we have in this logical level, we will discuss about the relation, tuple, attribute, cardinality, degree, primary key to vicinity. Okay. So we have the basic concept equivalent to logical level. A relation, table, tuple, row, a row or record. Attribute is a row or column. Cardinality is a number of rows. If you have a table and your cardinality, it counts for the number of rows. The degree is the number of columns. Primary key, it is what uniquely identifier. Domain is a pool Lego value. So in the logical level, normally we may talk about the table. A table is a collection of rows and columns. And the rows it is known as record. And the columns or data is known as a field. Let us take an example of a table of patient, a table of student, a table of a teacher. It is a relation. The characteristics of that table is what we call a column. A record is also known as a tuple. And a set intersection of row and column is what we call a cell. A degree normally it is a number of attributes. In our table. For our example of this table, the degree is 4. We have also what we call the cardinality. Cardinality for this table, we have how many columns? 1, 2, 3, 4. We have 4 columns. No, degree. Degree is a number of attribute. Means number of columns. And the cardinality is the number of records. So after designing on the logical level, you may think about the data type. Data type normally, as you have seen programming, data type are a set of values having predefined characteristics. So in the database, we have different data types. We have text, alphanumeric, numeric, Boolean, text, money. There are so many. So a relation can be represented in intension and extension. Intension, you list. In extension, it is given in the form of a table. The point number 3 on database design is physical level. On physical level, it deals with the storage. It is where you choose what the software to use. You can choose Microsoft Access, MySQL, Oracle, and so on. So on a query design, you need a practice. You will make the practice of it. Here we have the step for designing query. So after drawing the relationship diagram, think on logical level. You think about you put the practice what is done in the conceptual level, and then on the physical level you implement, and then you store what is. So the last point on this unit are rules of programming. or rules of database. So in database we have three rules. We have what you call the entity integrity. We have a domain integrity and the differential integrity. The first rule, integrity, normally it is concerned with the primary key. So each table should have a primary key, and that primary key, it is attribute, it is a column that should be unique and not null. The rules number 2, it is the differential integrity, concerned with the primary key. Differential integrity rules stated that any foreign key value can only be in two states. Usually it should be in the primary key in the parent table. So talking about the foreign key or differential integrity, you need at least more than two tables. Domain integrity means that all columns in the relation database must be declared upon a defined domain. Thank you for your attention. Thank you for hearing. Thank you for your reflection. Then we'll continue on next unity on, of course, on this unity. On database design step, the step for designing a database. Thank you. Have a nice day.